Learning Objective E is going to talk about how to tell if two equations are inverses of each other without graphing. What you would do is do function composition. The test is this. Find f of g of x, and you're going to see if it equals x. Then reverse it, do g of f of x to see if it equals x. If they both equal the value of x, then that proves mathematically they will be inverses of each other. Now be careful if they both equal something like this is 3x and 3x. That's not the same. It has to be x and x exactly. So let's walk through this one. Notice this notation. They're using f of x and f negative 1 of x. That just means inverse. If you prefer to write that as g of x, you could, but that's all that is. So here's what we're going to do. Let's find if it works. So we're going to do f of the negative 1 of x. Okay. This right here is just this function, so I'm going to replace it with that. So f of 1 over x minus 2. Okay, it tells me to go to the f function, which is right here. Wherever I see x, put this in its place. Let's be careful here. This gets a little tricky. It used to be 1 over x plus 2, but this is the actual x, so I have to put 1 over x minus 2. Now when you have a complex fraction, the way to get the fraction down here out of the bottom, easiest way is to multiply by its reciprocal, which is that. If you do it to the bottom of a fraction, you must do it to the top of the fraction. So in doing that, this cancels, the ones go away. So what we're left with is x minus 2 and then plus 2, which simplifies to x. This gives me the green light to go ahead and reverse the function composition. Let's see now if f of negative 1 of f of x actually works. By the way, if this hadn't equaled x, I would have just stopped and said, no, they're not inverses. Let's take f of x and put that in here. So f of negative 1, f of x is 1 over x plus 2. Now it says go to the f of negative 1 function, which is here. Wherever you see x, put that in its place. Again, just be careful. This was 1 over x minus 2. This goes in its place, so 1 over x plus 2. This plus 2 and minus 2 cancel, so we have 1 over x. To get this out of the bottom, multiply by the reciprocal. Cancels out nicely. You're left with x. So yes, these two are inverse functions of each other. And if this was on a test, I would probably graph these two on your calculator to see, remember, if they flip over the line. Y equals x is a great visual representation to see if two graphs are inverses of each other. Let's do this last one. They want us to show that f and g are not inverses of each other. So I'm just going to start off and do f of g of x. I'm going to take g of x, which is right here, and just substitute it in. Now it tells me to go to the f function, which is here. Wherever I see x, put that in its place. That'll give me 3, and then 1/3 x minus 4 plus 4. Distribute your 3 through, so that's 1x minus 12 plus 4. This is going to be x minus 8. I'm going to stop right there, say they're not inverses. By the way, you can visually tell if you graph these two, here's what they look like. They'll roughly look like this. You can clearly tell that if you take this red line and hold it steady and flip it, it technically looks like the inverse would have to go somewhere like that. Clearly the blue line is not the inverse, therefore they're not inverses of each other. Be careful, a picture can't answer your question. You must do the math to physically prove it.